Hello everyone and welcome to FreeCAD tutorials. In this tutorial we explain how to correctly design gear pairs in FreeCAD. Besides explaining how to design gears, we also go over basic formulas that will enable you to properly design your gears, and furthermore, these formulas will enable you to validate your design. Over here, as a proof of concept, we have modeled two gears and we will explain how to reproduce this model as well as how to verify that the geometry is correct. You can easily export these two gears as two STL files and you can easily 3D print them. I was able to do that and the 3D printed parts work really well. Before we start with modeling, let's briefly summarize the basic formulas that define two gears. These formulas will enable you to properly design the gear pair, and later on these formulas can help you to validate or to check the geometry. So let's start. The smaller gear, denoted by 1, is usually called pinion. The larger gear is called as gear. Every gear has a center. The center of the smaller one is C1 and the center of the larger one is C2. Here you can see the radius R1. This is the pitch radius. And here you can see the radius R2. This is the pitch radius of the larger gear. The distance between the center C1 and C2 is denoted by S. And obviously from this figure, S is equal to R1 plus R2. We denote the number of teeth as Z1 and Z2. Next, we can define the gear ratio. The gear ratio is the ratio of Z2 over Z1. One very important parameter that defines gears, or better to say gear pairs, is the gear module. The gear module is a number that is common for both pinion and gear. That is, both pinion and gear have the same gear module. From the basic kinematics of gears, it follows that R1 is the modulus multiplying the number of teeth of Z of 1, and this should be divided by 2. Similarly, R2 is M multiplying Z2 over 2, and these are two basic formulas. Okay, let's start with gear design. First of all, when you open FreeCAD, click on File and click on New to create a new document. Then click here on the document and then click on Part Design and click on Create Body. And here's our first body. Next, let's create our gear. Luckily, people who develop FreeCAD made it to be very simple. Simply click on Part Design, then click on this option over here, and over here you will see this menu. Now immediately over here you can select the number of teeth. You can select the module, and these are the two parameters that you should start playing with, and later on when you become more experienced you can change other parameters. In the future video tutorials we will explain the meaning of the pressure angle as well as the meaning of other parameters. So let's say that we want to create a pair of gears that has a gear ratio of 3. For that purpose, I'm going to select the number of teeth of the larger gear to be 30. And you can see immediately what happens once you change the number of gears. Just for illustration, if I put 50 over here, you will see how the gear number, or actually how the teeth number, is automatically updated. So let's now change this back to 30, and let's leave the module as it is. Good. And let's click OK. And now we have created a 2D sketch of our gear. If you now click here, you will see the parameters. You will see the module and you will see the number of gear. Now if we go back to our formulas, we can immediately over here calculate R2. Namely, the R2 will be modulus multiplying Z2 over 2. And we know immediately this distance over here. I'm going to use these distances later on in this video tutorial. Okay, now that we have our first gear, we need to extrude it. To extrude it, simply click on Body and click here, and you cannot do it like this. This is very, very important. So first of all, make sure that you click here, make sure that this is selected, and then click here, and then you can extrude. This is very, very important. And then let's extrude for 10 and click OK. And here it is. Here is our first gear. Perfect. My suggestion over here is to validate this 3D design by using these formulas. Namely, what I will do over here, I will calculate R2, and then I will calculate the corresponding diameter, and then I will sketch it over here, and we will compare it with the actual 3D design. So let's do that. First of all, click on body, and then over here click on sketch and click on create sketch, and select this plane XY plane. Now over here click and rotate everything such that you can see the back of the gear and such that you can see the coordinate system, and click here on bottom, and now pan the view. Let's create a circle by clicking here, create circle by center, and place the circle over here at 0 and 0. Okay, and specify any radius you like. So let's specify this radius approximately. Okay, now we didn't completely constrain this circle, we will do it later on, and do the right click. And then over here, if you can see, if you can click here, you can actually constrain the diameter. However, before we constrain the diameter, let's go back and let's perform simple calculations. Over here I opened the Python script, I specified the modulus that we enter in FreeCAD, and over here I enter Z230. Then over here I'm calculating R2 and I'm calculating D2 by using the previous formulas. Later on I'm going to also calculate S, however this is not important. So let's see over here what should be the radius R2. The radius R2 should be 37.5 and the diameter should be 75. Okay, so let's go here and then let's constrain the diameter. Click over here and then find constraint diameter, then click on a circle and enter here 75. And now if you enter 75, you can actually see that the design is correct. Since this circle approximately is between the top and the bottom surface of the teeth. And this is the first check, meaning that we are doing a good job. Or better to say, FreeCAD is doing a good job. Good. Do the right click and let's exit our sketch and let's return to the model. Okay, now when we are back in the model, we can continue further. Let's create the smaller gear. That is, let's create the pinion. If you want to exit the sketch, you can simply click close over here. That's another way. Okay, so let's go back here to the model and then let's create a new body. So make sure that you click on this document, unnamed, then do part design and click on create body. And here's our second body. Then make sure that you select this body, then click on part design and then click on this option over here. And then let's adjust the number of teeth. Since we want a gear ratio of 3, the pinion should have 10 teeth, and then press enter. Other parameters will be the same. If you now rotate and pan or translate this view, you will see the sketch over here. Let's now extrude this. To extrude this, make sure that you select this body, that body is selected, then click here, and then click over here to extrude, or you can actually click here to extrude and then specify 10 as the extrusion distance and click OK. And now over here, if you rotate, you'll see this top and bottom surface of the gears of the pinion gear. Of course, these two gears overlap, and the next step is to translate this gear. However, before we translate this gear, we can also validate that the radius is correct using the same principle. For that purpose, let's click here on body, and then over here, let's click on create sketch, and then again, let's select the plane, this plane over here, or we can just simply, let me see here, let me just be more precise here. If I rotate, I can select this plane and then XY plane, click OK. Let me see, yes, this is the correct plane. Good, perfect. Now, if we go back over here to Python script, we can perform the same calculations. We can calculate D1. And let's see what do we have for D1. It's 25. Good. So let's go back here and let's create a circle. Again, you need to create a circle and then you just need to constrain its radius or diameter. Click here, click create circle by center, and then let's rotate this such that we see the coordinate system. Here it is. Let me just click here on bottom, click here, and then let's specify this to be 25, and that's it. And now you can clearly see over here that everything is designed as it should, since this circle or the pitch circle is approximately in the middle between the top and bottom surface. Good. Do the right click, click close to exit, and let's continue further. The next step is to translate the pinion for the center distance. That is, for this distance over here, such that we can create this nice figure and such that we can verify that our design is correct. To do that, you basically need to do the following. First of all, adjust this view. I will do it like this. And then, of course, body 1 is something that we want to translate. Then over here, do the right click on body 1. And here you need to click transform. And then you can transform it for the distance you want. However, this is a manual way of transforming or translating the object, and I don't suggest you to do that. So consequently, I will click on cancel. A better approach is to actually manually change everything. So if you click here, you have basically information, and you have this placement over here. If you open the placement, if you click here, you can adjust manually the placement of this object. And here you can specify translation and you can specify the rotation. So let's go back here and let's see what we need to do. The distance S is actually the distance that we need to translate for, and it's equal to 50. Good. So let's go here and then let's try clicking here, and we can see how the pinion nicely moves. And over here, let me specify 50 to see what will happen, and looks really, really good, right? Looks really, really nice. You can click here on top, and then you can also adjust the rotation. Here the axis of rotation is the z-axis. This is because 1 is written over here. And let's do rotation, and let's see, let's nicely rotate everything, and voila, here it is. And then let's just accept the changes and let's see what happened over here. Now if I rotate everything, you can see how nicely everything is being placed, and you can see how nicely we have validated our simulation results. This looks really, really nice, and you can change different views and you can see it. Okay, that's all for today, and thanks for watching.